Hello, this is Frank Owen, PolyX Engineering, San Luis Obispo, California. Welcome to another video in my series on control systems engineering. In this video, we'll look at a second example of an actual control system, and this is taken from lessons by my friend and colleague at the University of Bergamo in northern Italy, Professor Fabio Previti. This slide was included in the last example. Can't emphasize too much that when you are go into the real world and look at a real control system, you have to have this structure firmly in your mind, because the details that are involved in implementing a control system can be so complex and overwhelming you lose sight of this configuration. Again, we're looking at a control system that was developed in the Laboratorio di Automatica at the University of Bergamo in northern Italy. I've already said this, I'll say it again. It's very, very important to keep this structure in mind when you go and look at a real control system in the real world, and that those details tend to hide this structure. For this example, we're going to look at a control system that was developed to assist a human who has a back injury, so someone, perhaps a paraplegic, to move his muscles on his own for the purpose of exercising those muscles so they don't atrophy. If you have an uninjured human and the job is to lift the lower leg, the brain is the controller, and it sends an electrical signal down the spinal cord to actuate the muscles at the top of the thigh. These muscles are the actuators, and they lift the lower leg. One perceives the position of the leg by sight, but also by feel. You could do this in the dark also. And then actuation continues until the lower leg is at the desired height. One point to make here that's interesting is, even though this is not a wired control system like you would find in an industrial setting, the activity of the human mechanism in making a motion is a closed loop control. There's a closed control loop. So you don't have to design a control loop in the real world to have an example of a control loop. You have many examples of control loop yourself, and they basically work the same way with the same configuration of those four components that a industrial designed control loop does. But what happens is that if we have a person that has a severe back injury, a person who's broken their back and perhaps severed their spinal cord, then what happens is that the control signals from the brain down to the muscle to actuate the leg are interrupted. So we have to find an alternative path to actuate those muscles, since the primary path, the natural path down the spinal cord, is not working. What happens also with someone with paraplegia is that the lack of using the muscles makes those muscles atrophy. So there was a system that was developed at the Laboratorio di Automatica to fire the muscles to contract and to raise the lower leg. An ultrasound sensing system was used to measure the angle of the lower leg, and this angle is fed back into the controller so that it can be compared to the desired angle. Sorry about that. That should be desired angle. Let's look a little more closely at how this works. We have a closed loop system exactly like the one that was presented on the second slide in this series, and again we want to try to sort that out and have that clear to us. So first we'll identify the sensor. That's a very good place to start. And there's an ultrasonic sensor by a German company named Zebras. The controller nowadays is software in a laptop. The controller talks to the actuator and tells it to lift the lower leg. In this case, it's a stimulator that sends a signal, electrical signal, as we'll see in just a second, down to electrodes on the leg. So this stimulator sends signals, electrical signals, to the top of the thigh, and these muscles contract to lift the lower leg. The thing that is controlled is the angle of the lower leg, and thus with these 4 components we have a closed loop system, a loop, as we saw on the second slide. So let's see how this is used. Here's a picture actually of part of the control system, as we'll see. The electrical leads are used to activate the muscle, so they're just taped to the top of the thigh. And then the Zebra system uses ultrasound sensors to measure the angle of the lower leg. Ultrasound sensors are often non-contact and are non-obtrusive, so they can be hard to see. What happens is that for an injured patient to do physical therapy, the input signal is applied to the system to have him or her raise and lower his or her leg a number of times. A lot of times what has been done in the past with physical therapy for such patients is that the physical therapist actually moves the legs up and down him or herself, and that doesn't activate the muscles, but at least it moves them. With this system, the muscles are actually used to move the lower leg. Let's look at the signals used in this system a little bit. So there at the top is our diagram that we want to have firmly in mind, and at the bottom are examples of actual system signals that are used in this control loop. The red signal is called a reference signal. You can see that here, and what that means is that is the desired value. So what we're actually doing is we're putting in a sinusoid to have the patient move his or her leg up and down a number of times. And as you can see, that angle goes from about 118 degrees to about 143 degrees. You can see that over here on the right. There's the angle right there. The black signal is the actual value. This system is called tracking control. I like the term positioner better, but tracking controller is used in industry, and it's called a tracking controller because the output signal tracks the input signal. And as you can see here, it's doing a pretty good job. So the red signal is the desired value, and the black signal is the actual value, and the black signal is following the red signal pretty well. And then also down here are the signals that are used, the command signals of the controller to the actuator. These are, I think, pulse width modulated signals. I don't want to go into the detail of that, but it just shows these 3 signals that are tracked down here are this value here, the desired value, that's the red. This is the blue signal here, and then the actual signal or the actual position here is plotted also on this upper plot. Let's look at a little bit of the hardware that is used here. First thing that we'll look at is the sensor hardware. So here's the sensor hardware. Controller, again, is often a computer, and more specifically it is software in the computer. This is actually block diagrams from the software program Simulink, so the controller can be written in Simulink. The plant is the leg itself, the lower leg specifically, because what we're controlling is we're controlling the angle of that lower leg. And then the actuator, this is the hardware used in the actuation system. There's our stimulator there, and then the other pieces of equipment that are part of that actuation. And that's the end of this example. Thanks for watching, and I hope to have you as a guest in an upcoming video. Thank you.